guys, it's Michelle. A lot of you work in modalities around gravity physics, space program that have to deal with models with movement. Not understanding movement in general will impair the way your model reacts and what needs to be done for the movement, whether it's artificial intelligence or robotics and so forth, as well as what we're coming up with for our space program. Movement is movement. So when you're looking at different ways of looking at what the arm does, let's say, right? And we have to come up with mechanical things, and we think that movement is one thing. It's like for some reason we think the hand is a claw. I don't know how that's possible when there can be over 1 million movements of your hand and the way it can move. What most people look at for movement models is a measurable outcome. Can I take something and pick it and move it 10 inches, let's say? And if I can do that consistently, then my model works. That doesn't work with the human body. If you look at something like this, just looking at, again, a movement model, we're looking at here a robot's arm. So what they were looking for is how to have enough movement from the base where it goes through the system, but also doesn't whip out and so forth. So again, see, there's that base. Base is big. How do we secure it? How do we secure it and add the rings to it, the O-ring? First of all, notice on this, there's no center point of movement. The movement is an exterior force. It's not looking at the interior movements. It's looking at the larger rotational movement. And that's not something the human body does. We are based off of interior movements. We are not meant for external movement. So that's what someone's doing right now, is stressing the unit from an exterior source. They're looking for a measure model of where it doesn't break down and how it responds. But to look at it, to think that that's what a vertebrae does, because then what the vertebrae also does is work on counterbalances. If you want less stress in the human body, you have to have more counterbalance. Not balance, not core strength, you have to more counterbalance. Stamina means ease of movement. And to counter a movement versus having a load of a movement, that's where you're going to get more of those dynamics. Now here's a movement coming from that, but they still have a secure base in how to do it, and look at where the movement is coming from. It's impossible almost in robotics to have the movement come from within. This is where we're humans. We have movement that comes from within. If I look at something like our own vertebrae, right? Most people think of a spinal column as something like this, one thing. And you can do, like if you took enough yoga or something, you could possibly do this kind of sphinx pose without using your hand. You would need some serious strength. But what's the problem with that? First of all, it's not a functional movement. Anything that you're using exterior muscle force or anything kind of controlled muscle force, when you can't do anything else, it's not a functional movement. I can stand here all day long. I can't dress myself with that. I can't feed my face and I can't brush my teeth. It is not a functional movement. If I go to the gym and lift a weight all day long, I might have an increased muscle mass, maybe an increased range of motion. It won't be sustained and the system will eventually break down because why? It's not talking to the brain. It's not a functional movement. The human body likes function, and that's how we're organized off of that. Cleverness is of, again, more core strength, exterior movement. And you're seeing that they might have more control for their models and stuff, but it's still not working. So getting back to the human vertebrae, each vertebrae, it has an individuality. So if I just look to the right and look to the left, you will start seeing little counters that going on. You don't see any of that in a store-bought model. I'm not trying to poo-poo their work, but again, I'm trying to give you measures of movement and models and what's the difference. I can't look at that and say, oh yes, that's how my spine works. So now again, where I talked about even vision, if I'm looking to the left or to the right, you will see my actions of just vision come through the water. But all that movement goes through each vertebrae separately. Now, it might look like one unit. There's little counters going on. Now, if I have a viscosity rate, where we talked about the other day about diabetes and such or whatever, changes, right? My fluid dynamics are off. You're going to see not the same gauge. I can look left or right. It's not reflected in here. And this is where people, when they have cancer and infections and so forth, it ruins or interferes with the dynamics of this organization of movement because it can't reflect or counter to the same degree as this. Now, if I was a high-end athlete, you would see the counter in so many different ways. And that's also, too, where, again, we go into those kind of avenues of movement, being a professional, but at the same time, a lot of professionals still don't understand how their bodies work. This model did come a long way. It is so immature to anything that we can do as human beings. It's not even funny. And to understand movement and how movement responds in relationship to gravity, that's why you're here and that's what you're learning about. So think a moment too, and if you have any kind of projects like this, I'd love your input. You can post them and then I can tell you what you're looking at in reviews with that and how it differs from the human body. Even though you're getting, let's say, from point A to point B, it doesn't mean that the function of movement is there. By not understanding that, eventually this will break down much quicker than it needs to, just like our bodies.